Okay, take a look at this. I've got a circle over here with this as the center. Let's call the center O. Okay, all look at the screen, please. Wait one. 陈卓, look at the screen. That's the center of the circle. I am now going to draw an angle. I'm going to draw a sector. So this is a sector, right? And I've got an angle over here. This angle, we're going to call it angle at the center. Can you all see why it is called angle at the center? Because it's an angle at the center. Okay, now I'm going to draw another angle. Okay, so these 2 points, they meet over here. What shall we call this angle over here? If the center one is called angle at the center, what do you think we can call the one at the top? Angle at the circumference, okay? Let's use that, angle at the circumference. Do you think there's a relationship between the angle at the center and angle at the circumference? If you think there is, then what is the relationship? Is there a relationship? You talk to your partner for a while. Center to up. You mean like this? And then what? I have an isosceles triangle, okay? You mean like this? And then? Okay, this one also, and then? Top angle is the same. You mean this one is A, then this one also A, is it? Why? Must it be the case? Why? What is your reason that they must be the same? What if I draw it this way? Okay, like that. So you get your same isosceles triangle. So this one you wanted to call it A, right? Let's call this A. Are you going to call this A also? No. So are they the same? No. Okay, then how? Call it B, is it? Okay, let's call it B. So this one is B. Then what do we do? Okay, this is also B. Then it's also A, isn't it? So I say A. And then what happens? Are you all seeing it already? Okay, what is this angle over here? 180 degrees minus 2A. If you don't have the degrees, it becomes radian. So what about this angle over here?
180
minus 2B. Then what about this angle?
2B plus 2A. 360 minus.
Okay, 360 degrees minus 180 degrees minus 2A minus 180 degrees minus 2B. All of you agree? Yeah. And what does this give us? 2A plus 2B. Which is the same as 2 times of A plus B. Where is A plus B? Where is A plus B? Here, this is your A plus B. So in summary, we have just discovered something. You discovered it? Okay, let's call it Chen Zhuo's rule, okay? Chen Zhuo's law. So if this one is called theta, then this being the center, this one must be 2 theta. In this original question, we had it as A plus B. Then our final angle at the center is actually 2 times of A plus B. So instead of calling it A plus B and 2 times of A plus B, you just call it theta and 2 theta. And 2 theta over here. Yes, this is recorded. Okay, so we don't have to go through this proof every single time. We can just quote it. And we call this angle at center equals 2 angle at circumference. Yes. Okay? Simple enough? Short enough for you? No extra words. That's all. Let's try an example. So if I give you a circle over here, this being the center, this is 50 degrees. Then how much is how much is this theta? 25 degrees. Okay, theta equals to 25 degrees. But can I just write it like this? What is the working like? Okay, theta equals to 50 degrees divided by 2. And we get 25 degrees. Then you write the reason on this side. Angle at center equals to angle at circumference. Okay? Done. Simple? If I go the other way, can you do it? If I give you the angle at circumference, can you tell me angle at the center? Okay, good. What about this one? Let's call this alpha. What is alpha now?
2 alpha.
What is alpha equals to?
2 alpha.
What 2 alpha? Where got 2 alpha? How much is it? Well, how you get 25? I want to work it. 50 degrees divided by 2. Angle at center equals 2 angle at circumference, right? And we get 25 degrees. Can? Let's try something else. Slightly different. I'm going to draw along the radius. I'm going to draw along the radius. I'm going to come down this way. Okay, let's call this beta. How about beta? How much is beta? Is it still 50 divided by 2? Why not? You see, the only restriction that I had was these angles must be at the circumference. Then I compare it with the angle at the center. And they must all have start and end at the same point. So does the last angle beta fit all these criteria? Yes, it does. So angle beta is still an angle at the circumference. And it is still bounded by these two same points, which bounds my angle at the center. So what is therefore the value for beta? It's still 50 divided by 2. Angle at center equals angle at circumference. And we still get 25 degrees. Do you want me to do some more, or you're convinced already? Then I'm going to show you something else. Yes? Extend outside. Circle, then go out. Don't understand, eh? Then what, like that? I don't understand. You take the marker, come and board and draw. While for the rest of you, I want to show you magic. Okay, watch carefully. The 3 theta, alpha, beta, what is the value?
25.
All 25, right? Is it a coincidence that they are same?
No.
It's not a coincidence, huh? They are all related by these reasons, right? Now I'm going to remove the angle at the center. What do you see now? If you see a shape like this, where all these 3 angles are at the circumference, and they're all at the same, they all start and end at the same point, then the angles must be the same. Does that make sense to you? Right? Theta, alpha, and beta, we found that they are all 25 degrees because of this reason. Even if I change the center angle, if I change it to, for example, 60, all your theta, alpha, and beta will all become 30. They are all the same. So here we have another relationship between theta, alpha, and beta. That is, they have the same angle. And now we call this... No. Okay. We're going to say that alpha equals to theta equals to beta in this case. We're going to say the reason is angles in the same segment. Hey, where's the segment? Okay, remember what a segment looks like. If I have a circle, I draw a chord. This is a segment, minor segment. Whereas over here, we've got a major segment. So where exactly is the segment? Between these two. This, I'm going to highlight the segment now. These are 3 angles in the same segment. Can you see that? So angles in the same segment are equal. This is the next thing that we need to learn in 10.2. So we have learned 2 things already. First, angle in the center is 2 times angle at the circumference. The next one is angles in the same segment. This is the abbreviation. What is useful is that these 3 angles are the same. Can? Anybody lost? Okay, so just a quick check. For if this is 30 degrees, how much is this angle? 30. Wow, so simple, right? Then how much is this angle? 30. Yeah, because they all started here and they all ended here. They are all angles at the circumference. Now, if I say that this over here is the center, how much is this angle at the center? 60. 60. And you must know all the reasons why, okay? So let's pause. Angle at the center is 2 angle at the circumference. Okay, let me widen the angle at the center. Let me widen it to look like this. What is an estimate of this angle? Estimate. How much is it? 160 160 degrees. So if this is 160, how much is this? What is this? 80, yes, very good. Let me exaggerate some more. Let me extend it some more. Let me extend it to look like this. This is now 178 degrees. How much is this angle? How much is it? 80? 80 what? 89 degrees. What is the reason? Angle at the center equals to? 2 angles at the circumference. What do you think I'm trying to do over here? I increase from 60 to 100 and, what was that, 160, I can't remember, until 178. What do you think I'll do next? Let's see what happens when it's 180. Okay, so now this is the center. This is 180 degrees. How much is this angle now? 90. It's 90 degrees. What is this shape over here? One that I highlighted. It is a semicircle because here I've got a diameter already. That's 180 degrees. What can you tell me about an angle in a semicircle? What is the angle in a semicircle? 90 degrees. Does it matter where my triangle is inside the semicircle? For example, it can look like this. It can look like this, isn't it? This is still a triangle, it's still an angle in a semicircle. What do you think this angle is going to be? It's also 90 degrees. Even if I draw it this way, what is this angle? It is still 90 degrees. So what is our conclusion? Angles in a semicircle is 90 degrees. And what is the abbreviation? We call it angle in semicircle. Okay, all of you have your circles, right? You have a diameter already. You can draw any triangle you want from one point of the diameter to the circumference and down to the other part of the diameter. You confirm get 90 degrees. Yes?
The spot doesn't have to be like
The which part?
the yellow spot.
No, that is the diameter.
Can it?
And your diameter not pass through the center?
No, I think can it not be the diameter? Can it be like mine?
Cannot. Because this rule is angle in a semicircle. And we got this from angle at the center is to angle at the circumference. So if I move the chord down such that it doesn't pass through the center, then I cannot use my angle at the center equal to angle at the circumference. Okay, so these are the 3 things that we have learned today, in addition to 10.1.